star networks are one of the most common computer network topologies. In its simplest form, a star network consists of one central switch, hub or computer, which act as a conduit to transmit messages. This consists of a central node, to which all other nodes are connected. This central node provides a common connection point for all nodes through a hub. In star topology, every node is connected to a central node called a hub or switch. The switch is the server and the peripherals are the clients. Thus, the hub and leaf nodes, and the transmission lines between them, form a graph with the topology of a star. If the central node is passive, the originating node must be able to tolerate the reception of an echo of its own transmission, delayed by the two-way transmission time plus any delay generated in the central node. An active star network has an active central node that usually has the means to prevent echo-related problems. The star topology reduces the damage caused by line failure by connecting all of the systems to a central node. When applied to a bus-based network, this central hub rebroadcasts all transmissions received from any peripheral node to all peripheral nodes on the network, sometimes including the originating node. All peripheral nodes may thus communicate with all others by transmitting to, and receiving from, the central node only. The failure of a transmission line linking any peripheral node to the central node will result in the isolation of that peripheral node from all others, but the rest of the systems will be unaffected. It is also designed with each node connected directly to a central network hub, switch, or concentrator. Data on a star network passes through the hub, switch, or concentrator before continuing to its destination. The hub, switch, or concentrator manages and controls all functions of the network. It also acts as a repeater for the data flow. This configuration is common with twisted pair cable. However, it can also be used with coaxial cable or optical fiber cable. Advantages and disadvantages. Advantages: better performance. Star topology prevents the passing of data packets through an excessive number of nodes. At most, 3 devices and 2 links are involved in any communication between any 2 devices. Although this topology places a huge overhead on the central hub, with adequate capacity, the hub very high utilization by one device without affecting others. Isolation of devices. Each device is inherently isolated by the link that connects it to the hub. This makes the isolation of individual devices straightforward and amounts to disconnecting each device from the others. This isolation also prevents any non-centralized failure from affecting the network. Benefits from centralization: as the central hub is the bottleneck, increasing its capacity, or connecting additional devices to it, increases the size of the network very easily. Centralization also allows the inspection of traffic through the network. This facilitates analysis of the traffic and detection of suspicious behavior. Easy to detect faults and to remove parts. No disruptions to the network when connecting or removing devices. Installation and configuration is easy since every one device only requires a link and one input-output port to connect it to any other device. Disadvantages: reliance on central device. Star topology relies on the central device, and if this device fails, the whole network will fail in turn. Higher costs. The need for a central device increases costs compared to the bus and ring topologies. The star topology also requires more cable when using Ethernet cables than ring and bus topologies. Limited capacity for nodes. As this type of network needs all connections to go through a central device, the amount of nodes in a network is limited by this factor, whereas bus and ring topologies are not limited in such a way. References